Hey team, just doing a quick sound check. Are we all good to go? Sorry, just been a bit distracted with a few things. Hey Masha, how you doing? All right, so we're going to be doing basic integration today. Just want to check where we're at. Kinematics. I'm all right. Just we've got a lot of work at the moment and looking forward to the break as well. Where is integration? I can't find integration. Hang on, let me just grab my notes and then we can get going, right? Integration. All right, here we go. So basically today, folks, we're going to be kind of covering integration, which is also known as anti-differentiation, which is going the opposite way of doing things for differentiation. So we're going to be doing some basic integration first, and then after that we'll attempt some exam questions, and then if we are good, I think today we'll probably do like finding C values and a couple of exam questions, and that's basically it. That should cover us today. So if it's stuff that you've already done before, then yeah, feel free to do what you need to do. No worries, Razel. That's the whole point of this whole exercise. All right, so let's actually go with just a quick recap of differentiation. So when we do differentiation, how's this looking? Yeah, this is looking good. So if we have y equals to axn, then we would say that y dash is a times n times x n minus 1. So this is what differentiation is. Now, when it comes to integration, or anti-differentiation as it's known, so what happens is that if you have, and so there's a couple of things, new things that's going to come up. So the first thing is the integral sign itself. So this sign here, this is what we know as the integral sign. And then the dx is basically telling you that we need to integrate with respect to x. Now the formula is, I don't know if your formula is actually given to you in your exam formula sheet, but all I know is that you do so many of these things and you just kind of get used to it. It's fairly straightforward. After a while, you don't even look at the formula sheet. Hey Jaden, how did it go? Micah, Vishal, welcome. So the way we integrate is we actually, instead of doing subtracting the power, we actually add 1 to the power, and we also divide by the new power, which happens to be n plus 1. So whatever that n plus 1 is, the new power is, you've got to divide by it. Now there's one particular thing that's really, really important with integration, is you have to actually, when you integrate anything, you have to put the plus c. The reason we have to put plus c is because I'm going to show you an example here. So let's say we have y equals x cubed plus 3. All right, now when we differentiate this, we're going to get 3x squared. Now, however, when we integrate 3x squared dx, what's going to happen is we're going to write this as 3x. We're going to add the power, which is 2 plus 1, divide by 2 plus 1. And what you end up with is 3x cubed over 3. Now the two 3's cancel out and you're left over with x cubed. But notice how when we integrate it, we kind of forget that plus 3 part of it. So we don't know if the original function had a number or not. So because we don't know what that number is, that is why we put plus c, because we don't know what, when we integrate, we don't know if there's a constant there or not. So you always have to put a plus c. All right, so what we'll do is we'll do a couple of quick examples. Simon, no, I think when you integrate, it's just at the start, the integral sign will be there. But then after when you start integrating it, you don't really need to worry about the integral sign. So yeah, Marcus tomorrow. Good luck for it, Kai. So what we'll do is we'll do a couple of quick little questions, and then I'll see if I can find some exam questions. So let's try this one here. I would like you to find that's it. 4x. So let's try those 3 questions there. What's the stuff in red for? The red is just letting you know what's happening with the powers. So when you integrate, you've got to add 1 to the power, and you have to divide by the new power. Good luck, Micah, for it. So I'll give you folks a couple of minutes to try these questions, and then I've got to start looking for some exam questions, so bear with me. The exam questions generally are like find C value or something like that, which passes through 2.5. Okay, yeah, I've got a few questions already. Because trust me, I think once you start doing exam questions, this stuff just kind of makes sense. Oh, man. Hi, Aniket. All right, so let's do number 1 here. So number 1, I'm going to do it the long method here. So I've actually got 6x squared. So I'm going to add 1 to the power, divide by the new power, which is 2 plus 1. And of course, don't forget the plus c. So when I do this, I am going to end up with 6x cubed over 3 plus c. And then the 6 and 3 cancel out to leave just 2x cubed plus c. So that's number 1. Aniket, we're just starting integration. All right, now looking at question number 2. So question number 2, we're going to do 3x 2 plus 1 over 2 plus 7x. Now remember, x has a power of 1, so that's going to be 1 plus 1 over 1 plus 1. And then when it's a constant by itself, it just changes to minus 5x. I'm good, Skrill. I'm good. And once again, don't forget the plus c. So we've got 3x to the power of 3 over, I forgot the 2 plus 1 there, sorry. That should be 3 plus 7x squared over 2 minus 5x plus c. So simplifying this, the 2 3's are going to cancel out. I've got x cubed plus 7x squared over 2 minus 5x plus c. Tired today, man. I got so much work to do after this. I feel like going to sleep. All right, so question 3, we've got integral of 4x. So we're going to go 4x, 1 plus 1, which is a new power, and then minus 3x, and then don't forget the plus c. So we're going to get 4x squared over 2 minus 3x plus c. 4 and 2, that makes it 2, so we've got 2x squared minus 3x plus c. Okay, so I look, I'm not gonna lie, I only gonna want to spend like maybe about a couple of questions on this, and then we're gonna go straight into exam questions, because all of these exam questions that come through, they're all achieved questions, easy achieved questions, but mainly most of them is they will ask you to find the constant. So they'll actually give you a value, like a x and y value, and then they'll just ask like variety of combinations of those things, right? So what we're going to do is let's have a quick look at an example. Now, by the way, is there any questions from there? Nah, not today, 100 ping. We won't go to any E questions. Maybe merit, because this is like a just kicking things off at the moment. Hello, Zephania? Yeah, I think once you get to kinematics, which I think we're going to be doing in about 2 sessions time, that's when you use, that's when all the excellence questions come through. Ravi, I wouldn't put 4.5, 3.5, yes, not 4.5. Would recommend it, Vince, would recommend it. Okay, so the next example that we're going to look at is finding C value, right? So what generally happens is you might get a question something like this. Curve goes through, I don't know, I'm just going to make up these questions here. It goes through 2, negative 2, 3, 2, negative 3, and has gradient function. So it might look something like this. dy over dx, 3x squared minus 8x plus 1, and then they'll say find equation of curve. All right, so basically what I would like you to do is remember that in this question you have been given f dash of x, which is 3x squared minus 8x plus 1. Now this particular part, find equation of the curve, what they are asking for is, they are asking you to find f of x. So all you need to do is you just need to integrate it, and when you integrate it, remember you're given a point. So this particular thing, when it says f of negative 2 equals to 3, so this is just another way of writing f of negative 2 equals to 3. So what we're going to do, and I'll do this part with you for the first one so you kind of get the hang of it, and then we'll do a couple of questions, all right? So I'm going to integrate this. So I could rewrite this as just f of x equals 3x. I've got 2 plus 1 divided by 2 plus 1 minus 8x, and as for the power, 1 plus 1, 1 plus 1, and then I've got plus 1x, and don't forget the plus c. So then I can say f of x equals 3x cubed over 3 minus 8x squared over 2 plus x plus c. So f of x equals x cubed minus 4x squared plus x plus c. Now I need to figure out what the c value is, and to figure out what the c value is, I am going to use this. F of negative 2 is equal to 3. So that means I can write down 3 equals, wherever x is, I'm going to put negative 2 minus 4 times negative 2 squared plus negative 2 plus c. So when I do this, I'm going to get minus 8 for negative 16 minus 2 plus c. So basically I'm getting 3 minus 26 plus C. Rearranging it, I'm going to get C is equal to 3 plus 26, and I've got C is equal to 29. So then my equation of the curve is going to be x cubed minus 4x squared plus x plus 29. And this is pretty much what we need to do to find... Oh no, what happened? Did it crash? Oh, sorry guys. What happened? What happened? Why did it crash? All right, give me a second. Let me just figure out what happened. It looks like a sync issue. All that work. No. See, this is what happens when I don't look at things and just kind of start doing things on my own. All right, here we go. That's better. Sorry, I didn't realize that. Apologies. Okay, so there we go. I thought it actually kind of worked through it. Now look, what I'll do is I'll leave it up here, and I'll put some line numbers for you guys. So if you do have any questions, just feel free to yell out. So I think you were up to the part where it was line 5. So line 6 is when I started kind of substituting things and just kind of doing things on my own. Is there any questions about what I've done there so far? Because all I've done there is I've just substituted f of negative 2 as 3 in here. That's what I do to try and figure out what the C value is. Now let me know if you're okay with this. If you're okay, I can put up another question. If you have some questions, feel free to ask. Or am I just gone on silent? Is it still working? 826.33. Yeah, looks all right. Integral sine f of x dx. No. Integral sine. So it's kind of like this. Sorry, let me just write this in red so you can kind of see that. So f of x is equal to integral of f dash of x dx, if that makes sense. Because you're integrating the gradient function in this case. All right, so exam questions? I need to know. All right, again, these are all achieved questions. So I will see if I can try and find us a merit question as we work through this. And the thing is, guys, you'll get the hang of achieved questions fairly easily because they just... Oh, where's the question? Come on. Sync the notebook. Still waiting for the question to come. Oh, come on, man. Sync now. It's being a pain. Ah, there we go. All right. There you go. That's your first question. Try this out. And what I'll do is I'll see if I can find a few other questions like that. I've got an old excellence question there, Aniket. I just found it, but I think it's a pretty decent excellence question. But I think it might be a merit nowadays, but we can try it out. What I might do is I might do a couple of more achieved questions, and then after that we'll try out the excellence question. I'll copy it down anyway. Oh, we're getting a couple of different answers here. I like this question. There's a couple of cracker questions tonight, so all right, let's do this question here. We've got a few different answers here, so it's interesting. But we know we're only looking for one answer here. So we've got g dash of x is that. So g of x is equal to 6x. We're going to go 2 plus 1 divided by 2 plus 1 minus 5x plus c. So g of x equals 6x cubed over 3 minus 5x plus c. G of x equals 2x cubed minus 5x plus c. Now we know that it's going through the point 1, 4. So g of 1 is equal to 4. So 4 equals 2 times 1 cubed minus 5 times 1 plus c. We're going to get 4 equals to 2 minus 5 plus c. 4 equals negative 3 plus c, and c is equal to 7. So g of x equals 2x cubed minus 5x plus 7. Even if you square it, 3 minus 2. Don't know how you got that one, man. All right, now the next question. I'm just trying to look for seven. All right, one more achieved question, and then we'll try. We'll actually try probably an excellence question straight up. Just gonna throw you in the deep end. Now the excellence question and integration, they tend to be like they usually end up doing like something to do with like simultaneous equations. But all right, so one more achieved question. Oh, welcome back, Durian. We're gonna be doing graphing. Like I'm gonna spend a whole session on graphing next week, man. I think most people fly over my house. Okay. How do we do that? Without learners. Without learners. I have an idea. We got -3,9 and we got 3,9. Okay, all right, let's try this then. So if f dash of x is that, f of x equals to 4x squared over 2 plus 3x plus c. So f of x equals 2x squared plus 3x plus c. Now it actually says that it passes through the point 0, 0, which means f of 0 equals to 0. Now this is a good one because all you have to do is just go 0, 2 times 0 squared plus 3 times 0 plus c. When a curve actually passes through 0, 0, you can automatically say the c value is equal to 0. You don't actually need to show the working. Because remember, anytime you have an equation, remember when you have like y equals mx plus c, if it goes through the origin, then your c value is going to be 0 because c is the y-intercept. So that's another language that might come handy for you guys. So when they say like when they say it's the y-intercept is 3, that basically means that c is equal to 3. Okay, it's alright, I'll do it again because basically that squared is just 1 plus 1 because x has a power of 1, Jamil. I just did that a little bit faster because remember that f dash of x is 4x to the power of 1. Okay, so that means we've got f of x is equal to 2x squared plus 3x. We've got f of -3, which is 2 times -3 squared plus 3 times -3. That's going to be 18 minus 9. So the coordinates on the point where x equals to 3 is going to be -3, 9. All right, so let me know what we want to do. Do you want to try another achieved question, or do you think you want to try an excellence one? Of course we do. I don't know if it's an excellence or a merit one. I'm just trying to have a look at this question. I get a feeling it might be excellence. Yeah, I'm sure. I'm sure this has to be an excellence. Not this one. We're going to try this one here. I'm nervous putting this up here for you folks, but we'll be all right. How do we figure out? So I'm thinking this is something that you do know how to do it. It's pretty much using all the things that we've learned so far. Probably next week sometime, right, Jamil? I'm trying to think about how to do this. Gradient is equal to that. Y coordinate of the minimum turning point of the curve is 10. Have you already done it? Damn. How did you do it so fast? Yeah, x equals 0 or 2. So the minimum would be at 2. Ah, maybe you're right. Maybe it's not. Maybe it's not an excellence question. Maybe it's just a merit question, maybe. I need to look at the schedule. Hang on. I'll find the schedule to see what question this was, because that just looks too easy. I thought it would be a little bit harder than that. Resources. Why does my eDrive take so long? 262. Is it? Schedules 2013. What is the 6x squared minus? Wow, this is an excellence question back in the day. Insane. You don't even need to prove which one is a minimum. Wow, that's crazy. Okay. All right. So yeah, just kind of doing this question. I'm just surprised that this was an excellence back in the day. So we've got 6x 2 plus 1 over 2 plus 1 minus 12x 1 plus 1 over 1 plus 1. And don't forget the plus c. So we've got f of x equals 6x cubed over 3 minus 12x squared over 2 plus c. So f of x equals to 2x cubed minus 6x squared plus c. Now to figure out, thanks Benjamin, to figure out what that c value is, it does tell us that the y coordinate of the minimum turning point is 10. Now we've got to figure out what the x values for the turning points are. And if you remember, for turning points, remember that f dash of x is equal to 0. So we've got 0 equals 6x squared minus 12x. Factorizing this, I'm going to get 6x and x minus 2. Therefore, x is equal to 0, or x minus 2 equals to 0, and x equals to 2. Now, this happens to be a positive. So this right here, this is a positive cubic, and because it's a positive cubic, it's going to look like this. And what we know is that's your local maximum, and that happens to be your minimum. So if the y coordinate of the minimum is 10, then what we have is we've actually got f of 2 equals to 10, because that's the y coordinate. So then we can say 10 equals 2 times 2 cubed minus 6 times 2 squared plus c. So we're going to get 10 is equal to 16 minus 24 plus c. 10 equals minus 8 plus c. And then c is equal to 18. So therefore the curve y equals 2x cubed minus 6x squared plus 18. That's ridiculously easy for an excellence. So this was from this is one of the older papers, 2013. Such an easy excellence question. All right, let's try another excellence question then. We might as well keep going. Where is this one? Oh, actually, I'm going to pause here. Does anybody have any questions on this, or are we good to go to the next question? I know, right, Dahlia? Like, I remember seeing some of the excellence questions from like back in the day. They were so easy, ridiculously easy. All right, we're good. Okay, let's go next excellence question then. Now this one here, I'm going to give you a hint straight up. You've got to use simultaneous equations. I'll give you folks, have a go, see how it goes out. I think you need to use simultaneous equations, do you? Yeah, you probably do. Jaden, this is 2013. I'm like going through some of the older exam questions. Then yeah, just after that we'll get to the newer ones. It's funny, they always have the standard achieved questions, like which just give you an equation, find the value of C and find the equation. They always do that. (2022) was annoying paper. C equals 6 and C equals 6. Equation of the curve is that. Got stuck. It's alright, we'll go through the questions. Give me a second, I'll just pull up my notes. Yep. Depends where you get stuck at. Where'd you get stuck, Aniket? Because look, here's what we're going to do. We know that f of x equals mx 1 plus 1 divided by 1 plus 1 plus 2x plus c. So then we can say f of x equals mx squared over 2 plus 2x plus c. Now, what it says is that we've got it going through point 210 and as well as -1 and -8. So Aniket, what you have to do is you've got to create two sets of equations. All right, so the first equation I'm going to do is 2 and 10. Then the next one I'm going to do is -1 and -8. So when I do that, I'm going to get 10 equals m times 2 squared over 2 plus 2 times 2 plus c. Then I've got 10 equals m times, that's 4 over 2. So that's going to become 2 plus 4 plus c. Rearranging this, I'm going to get 10 minus 4 equals 2m plus c. So 6 equals 2m plus c. I'm going to repeat the same process for -1 and -8. So I've got -8 equals m times -1 squared over 2 plus 2 times -1 plus c. So I've got -8 equals m times 1 over 2, so that's going to become 0.5 minus 2 plus c. Then I've got -8 plus 2 equals 0.5m plus c. So I've got -6 equals 0.5m plus c. Yeah, so these types of questions, right, like the simultaneous equation question is very common in calculus. So they'll always put like either with differentiation or integration, where you'll have to use simultaneous equations to try and solve these questions. Now, once you get the two simultaneous equation questions, it's pretty easy because you got 2m plus c equals to 6, 0.5m plus c equals -6. So you don't need to show any working. You can go straight to the graphics calculator and get your answers from there. So we can just go menu and go down to equation, simultaneous 2, and just put in these values. So we've got 2, 1, 6, 0.5, 1, and -6. So when we do that, we get m equals 8, c equals -10. So the equation is going to be f of x equals 8x squared over 2 plus 2x minus 10. Or 4x squared. Yep, you got that. Now, Aniket, if you do get stuck like that, right? Like it's a good place to be at, because when you get stuck like that, you go back and read the question, because most of the time when you read a question, you kind of like rush through it. You just get like one bit of information and then you forget to read the rest of the question, and they usually have like clues in there that you've got to look for. It was actually not a bad question, was it? Like, I mean, just needed the little clue, and then off you go. You were off. Looking for the next one. Geez, there's lots of these achieved questions, not so much. '21 maybe, 2021. Merit. All right, let's have a look. 2021, 2020. Equation of tangent, f dash fx curve. Oh, funny. This is similar question. In fact, almost exactly the same question. Try this one out. This is from 2020, so it's quite recent. The first one we did was this current question that we're looking at, the question F, that was from 2013. And then we've got a similar question like that from 2020. Oh no, sorry, I missed the ads. Damn it. Thanks, Corbin. Hey, Shaman, how's it going? Communist, yes, I can. To do this manually, what I could do, sorry, I'm just going to do it really, apologies about that. Just to do that manually, because you've got 2m plus c equals to 6, 0.5m plus c equals -6, because I can just subtract c minus c, and what that means is that I'm going to get 2 minus 0.5 is 1.5m, c minus c is 0, 6 minus -6 is 12, so m equals 12 divided by 1.5, which equals to 8. And then 2 times m plus c equals to 6. 2 times 8 plus c equals 6. 16 plus c equals 6. C is 6 minus 16. And that's going to give you negative 10. Yeah, hopefully that helped you, communists. So, all right, next question. Similar one. In fact, exactly the same one there. There we go. While you guys try that, that's terrible, Dali. It's terrible. All right, try this question. Pretty much the same one as last time, folks. Where did it go? There it is. 2020, 18. Let's try 18. It's kind of tricky trying to find like similar type of excellence questions or like any other. Oh, wait. No, it's a tangent question. Shaman, this is gonna be my last question for the night. Well, unless it's not if it's not a too crazy one, then yeah, sure, why not? See, I was thinking what NCEA should do is they should just hire me as a nighttime teacher, and instead of going to school, I just do this 1 hour or 2 hours a night, just with level 2s and level 3s. I'll be happy with that, man. They should just hire me instead of being a full-time teacher. And then during the daytime, I don't know, go play golf, do some gardening, something. Fat Bunda. Yeah, I don't think I will be stopping it anytime soon. 100 ping, man. You're like on like fire at the moment. Just burning through these questions. What's funny, because I think start of this topic you were like, oh, I don't know how to do this. You're kind of like slowing down, and then suddenly you just picked up pace. Shaman, it's going to be sine to the power of 4x over 4. So actually, it's sine x to the power of 4 divided by 4 plus c. Use substitution, man. Like, substitution will make it so much easier. Sorry, I'm just going to do this on the side. Yeah, like reverse chain rule is what you would use. Because then this would become sine 4x over 4 divided by, that's one way of doing it. A couple of ways of doing it. All right, folks, I'm going to do this last one here. Substitution is beautiful. I'm not going to lie. I love substitution. Integration by substitution is like, it just works beautifully. All right, let's try this question here. So this one here, it's going to be pretty much the last question for the night. So what do we got? We've got f dash of x is that. So f of x equals px squared over 2 minus 4x plus c. we've got 412. So 12 is equal to P 4 squared over 2 minus 4 times 4 plus C. 12 is equal to 16 over 2 is 8. So 8P minus 16 plus C. So we're going to get 12 plus 16 equals 8P plus C. We got 28, 8P plus C. Now that's for 4 and 12. Then we've got negative 6 and 2. So 2 equals P negative 6 squared over 2 minus 4 times negative 6 plus C. We've got 2 P negative 6 squared is 36 divided by 2 is 18 plus 24 plus C. Rearrange, we've got 2 minus 24 equals 18P plus C. So we're going to get negative 22 equals 18P plus C. Super sorry, just going to be exceptionally lazy here and just use the calculator. So we've got 18, 1, and negative 22. Then we've got 8, 1, and 28. Ooh, did I make a mistake somewhere? I feel like I made a mistake somewhere because these numbers are just not pretty. What have I done wrong here? Where's 100 ping? What did I make a mistake with, guys? Where did I make the mistake? $18, not 17. Huh? Where did I make the mistake? Because this does not look right. Oh, it's right. 18 there. Okay, yeah, I see. The calculator. I put it in the calculator wrong. There we go. That's better. Thank you, Jaden. All right, so then P is equal to negative 5. C is equal to 68. So our equation is going to be f of x equals negative 5 x squared over 2 minus 4x plus 68. Thanks, Jaden. Appreciate it. All right, people. I think that is pretty much... We've just done some crazy questions for integration. Yeah. We've done all of that. Rate of change, gradient. Okay, I think what we're going to do next session is we're going to go graphs. Doing all graphs next session. By the way, next session, can you folks... we're going to try something different. We're going to do this whole activity next session in Desmos. So I'm going to try and create an activity for you on Desmos, and hopefully it works. Because I've done it before once. We'll try it again, and that way you guys can actually draw the graphs, and I can actually see how you draw the graph. It's always fun doing that experiment, because there's always some kid that comes and draws a whole bunch of what do I call it? Penises. Let's just call it what it is. You draw a parabola, someone does a penis. So yeah, that's going to be a fun exercise to do. All right, folks, that is pretty much me today. Nah, graphs are so easy, Jaden, trust me. Once we do, like, I think it only takes like 1 hour to get the hang of those graphs. Now 100 ping, like, one of them tends to be achieved, and then one of them would be like merit sometimes. So, but I'm not gonna lie, like, I love doing the graphs because they are some of the easiest easiest grades you can pick up. Trust me, after 1 hour you'll be fine with it. So we'll do graphs on Tuesday. By the way, if you are keen to do an extra session so that we can kind of finish it before the term ends, let me know. I'll be keen to kind of like get this done by end of term. Yeah, 100 ping. I know what you mean by. Okay, that's good to know, Vishal. I might just do a couple of early ones. Keep an eye out this week. I'll try and see if I can get a couple out this week. No, because I want to start the revision stuff after that. Like in term 4, I just wanted to like spend time doing revision with you guys, just doing exam questions. And like now that we've got ChatGPT, we can actually get it to write different exam questions for us. I can block it off. There we go, Dahlia. I'll block it off. There you go. Yes, awesome. I know I was supposed to do it last week, but I've just been putting it off. I'm not gonna lie. I'll get some sleep tonight. I might actually do it tomorrow night. Thanks, keep it. Thanks, Aniket. All right, folks. Have a good night. I will see you Tuesday night for the next one for graphs. All right. Take care, guys. Catch you later.